everyone, and thank you, ISCA, for giving me the opportunity to speak today. As I've been listening to a lot of really fantastic presentations today and realized that it's about 4 o'clock, I've made a list of a few things that I'm not going to have in my presentation. No great videos, no photographs, cartoons, quotes from famous, and no deep philosophical thoughts from me. However, I have stolen a quote from a previous presenter who I thought was great. Why should I care about future generations? What have they ever done for me? And I think that was pretty spot on, but I want to start with the quote because I think that I've had the opportunity through this project to work with a few organizations who've risen above this and are actually trying to do something for the future generation, regardless of the fact that they haven't done anything for us yet. Also, I will try and incorporate coffee into my presentation at some stage. That's for you, Anthony. Do you know how to get this to work? Okay, so I just wanted to set the scene as to why this project was undertaken. The New South Wales EPA has decided that improving air quality for communities and the reduction of particulate matter arising from diesel emissions is a matter of priority for them, and they would like to do something to encourage contractors and construction industry to reduce emissions arising from diesel engine use. They've already undertaken a few programs. The Clean Machine program has been running for about 3 years now. It has come to an end. The EPA's Metropolitan branch is trying to undertake the Clearing the Air program, which is about to start. As part of that program, they're intending to bring in legislation, either as part of license conditions or as environmental application conditions. And they haven't decided how to go about it yet, but I am calling that the stick approach. However, coming to my project, it is the carrot approach, and we are trying to develop best practice case studies to determine or to reward those in the construction industry who are already doing something to reduce diesel emissions. So the aim of this project is to engage with ISCA members, which is all of you, and other stakeholders to identify, develop, and publish case studies on non-road diesel emission management implemented by the infrastructure industry. As part of ISCA's project management team, we've been trying to identify potential synergies with the IS rating scheme in the future. And we held an open forum for discussion with the EPA and between the industry, which a lot of you already attended, and thank you for that. I also want to say that if you didn't attend any of the forums and didn't know about this project already, please come and talk to me because our survey is still open. So as part of the project, the first step was an industry engagement survey, and the results of the survey were used to inform the content of the workshop, which was held on the 12th of September. As part of the workshop, we teased out and developed some concepts for case studies, which we are in the process of developing now, and are going to publish them on both ISCA and EPA websites. One of the case studies is going to be presented by Kate today, and thank you very much, Kate, for that. Before I go on and hand over to Kate, I just wanted to show you a couple of results from the survey. First up, the organizations were asked whether they have knowledge of previous EPA-run programs in order to reduce diesel emissions, and only 10 out of the 30 respondents said yes. So once again, here I am. We have another program where we're trying to engage with all of you. If you haven't heard about it or would like to talk more about it or would like to participate, please come and talk to me. The survey is still open until the 30th of October. The second thing we're trying to do was to determine what are the reasons behind the organizations who have implemented any of these projects and why did they implement them. So occupational health and safety and environmental policy were the two reasons why some of the diesel emission reduction projects have been undertaken so far. Once again, if you think there are other reasons behind you or your organization undertaking any projects to reduce diesel emissions, please come and talk to me or contribute to the survey or get in touch with the EPA. They'll be very happy to hear from you. And the case studies, one of the case studies that is going to be presented by Kate Cole today is the Sydney Metro Northwest, previously Northwest Rail Link. We also have a case study based on Blacktown City Council and Downer Group's innovation, and please keep an eye out for them on ISCA's website or on EPA website. You'll hear from us when they're ready to be published. Without further ado, I would hand over to Kate. Actually, I wanted to say that now that the project's over, it's about to be finished and put into the grave, and hopefully Kate will take it out of the coffin.
Thank you. Okay, so my name's Kate Cole. I'm a certified occupational hygienist and I'm an independent consultant into the Thiess John Holland Dragados joint venture. That's a very long word. I'm going to call it TJHD. So I'm an occupational hygienist and I'd like you to humour me. Could you please raise your hand if you know what an occupational hygienist is? Now I need you to put your hands down if you think it's got anything to do with teeth cleaning. So there's not many hands left. That's a bit disappointing. So I want to clarify what it is. Occupational hygienists use science and engineering to provide a safe and healthy work environment. We're all about the H in OH&S, and that's my primary focus. So hopefully this case study gives you a little bit of a different look at how important sustainability is just outside of the environmental space. Some of the things that occupational hygienists do is assess and control exposures to various hazardous substances, and in tunnelling, that includes things like respirable crystalline silica and diesel particulate matter, in addition to various exhaust gases, exposures to noise, thermal heat stress, using specific type of chemical protective equipment and PPE, and of course looking at physical hazards such as whole body and hand-arm vibration, to name a few. And all these things go together into the discipline of occupational hygiene. That's about as technical as I'm going to get today. So an overview of what I'll go through. Most importantly, the context and the key driver behind this case study. I'll take you through the management approach and strategy that was implemented, some of our lessons learnt, and most importantly, our key achievement to date. Well, first off, the construction of the North West Rail Link TSC contract, which is a tunnels and stations civil contract that this case study is based on, involved the construction of the longest rail tunnels ever to be built in this country. And that meant that temporary tunnel ventilation had to successfully address these extremely long, uninterrupted underground drives and provide fresh, clean air to the guys that were building the tunnels underground. There were 8 surface sites, which is similar to setting up a very large factory and digging basements for 7 large buildings in highly urbanised environments. And as hygienists, we were concerned of the impact of diesel exhaust gas and particulates on the health of tunnel workers and the surrounding community. Just quickly, some of those health impacts include short-term irritant effects and asphyxiation, and long-term chronic effects such as lung cancer, which may end you up in a coffin. But I should say from the outset that the development of this strategy and the implementation of this entire program was focused on continually improving work health and safety conditions for underground tunnel workers. That was our primary focus, but it also happened to have a fantastic flow-on effect because it helped protect our environment and the surrounding communities also. So the control of diesel emissions was considered across all the key phases of the TSC contract, from time of tender as part of design and planning, from contract award in terms of the procurement process, and during construction. And at each key phase, risks were identified and appropriate control measures determined. Monitoring forms a crucial part of any strategy, and this was no different. There was a comprehensive monitoring strategy that was put in place at time of construction. And Caitlin alluded to this before, but it's important to note that in most design, or in some design and construct contracts, that up to 90% of the work can actually be subcontracted out. But by stark contrast, TJHD directly employed over 550 tunnel workers, and they also directly procured key items of heavy plant and equipment. This meant that TJHD had far more control over the selection of plant and implementation of management and administrative measures than is typically the case. So, because of that, the TSC works are significantly different from other tunnelling contracts within this country, as the TBMs, road headers and other plant and equipment used to excavate the tunnels were procured directly by TJHD. The first TBM arrived in Australia in July 2014. That's just 1 year after contract award, and tunnelling commenced only a few short months later. The duration from contract award to tunnelling might sound like a long time, but it's actually incredibly short. So that meant that decisions needed to be made that impacted on the design of the TBM and the associated ventilation system well before contract award. In fact, it was done at time of tender as part of the design and planning phase, which is the best time to consider these types of risks and design them out wherever we can. Those particular decisions impacted not only on ventilation, but also extraction, so it moves the air and filters it through a scrubber system, and also helped us determine where the use of brattice and enclosures may be needed. So first off, during design, the target airflow in the tunnels was set well beyond the minimum requirements in the tunnelling environment. And that was done to reduce the amount of airborne contaminants, including things like diesel particulate matter and diesel exhaust gases, to provide a safe environment for underground tunnel workers. The ventilation system was designed to deliver, filter, and extract and remove more air than is needed, even though this would increase both plant and running costs. Fresh air, I should say, that's because we wanted to create a safe and healthy work environment for the tunnel workers, not to say it's not needed. Fresh air is supplied from outside the tunnel, from the portal, and it's supplied to the back of the tunnel boring machine through a vent bag, and that's shown in this yellow bag that's on the top of the TBM tunnel in the photograph. The air flows forward towards the cutter head, where it's aided through the use of extraction fans, and a scrubber system at the front of the TBM, where cutting is actually taking place, removes those airborne particulates, scrubs them out so that clean air is delivered at the surface. During the procurement phase, TGHD researched the latest procurement options available to them for key items of heavy plant. And for each piece of heavy machinery needed, it was asked if the piece of plant could be electric powered or diesel powered, and if it could be electric powered, then it was. And this resulted in a lower reliance on diesel-powered plant than is typical on most tunnelling contracts. And this included such crucial items as the tunnel boring machines, the road headers, shotcrete rigs, jumbo drills, and concrete pumps, to name a few. Where the use of diesel-powered plant was necessary, then TGHD ensured that all key items or large items of heavy machinery were either new or they were fitted with new engines that conform to the latest EU standards as referenced in the Government Resource Efficiency Policy, or the GREP, that you'd be familiar with. For example, there are 15 Caterpillar Meta-Alliance pieces of plant that conform with Euro Stage 3B emissions requirements on the project. And by procuring equipment with lower emission standards and implementing engineering controls, the amount of diesel emissions in the underground environment was significantly reduced. Additional administrative controls were implemented to both promote behavioural changes, but also to ensure diesel emissions were kept to levels that were as low as reasonably practicable. And that included things such as the use of low sulphur biodiesel and self-cleaning fuel, equipment allocation, which meant that equipment that emitted the lowest amount of emissions were allocated to sites surrounded by sensitive receptors, such as schools or hospitals. There was a restriction on the number of heavy pieces of plant that could operate at any one time. There were idling reduction programs that were put in place that included a heavy vehicle driver code of conduct. And there was a monthly maintenance regime which involved physical testing of the exhaust emissions of all the key items of heavy plant, in addition to a comprehensive education program. So on education, as part of managing diesel awareness, all underground workers sat through a comprehensive underground induction. And part of that induction, the best bit of it, was that they got over 2 hours training about occupational hygiene, which was really exciting. And a significant portion of that was about the toxic effects of diesel exhaust emissions and particulates and the reasons why all those control measures were there to protect them and their part in that process as well. Monitoring forms an essential part of any strategy because it helps us determine if all the control measures we have in place are actually working and if they're actually effective. Sampling occurs on a regular basis by independent occupational hygienists, and we use the results to determine if further controls or adjustments are needed over time. If concentrations of things such as diesel particulate matter or other diesel exhaust gases do start to rise or they are slightly elevated, then additional control measures are implemented as part of an adaptive management approach. So here are the results of samples collected, exposure samples collected for diesel particulate matter. Diesel particulate matter, not to confuse the issue, is measured in terms of a surrogate as elemental carbon. And the red line represents the adopted exposure standard on the project. It's prudent to point out that neither Safe Work Australia nor our state-based health and safety regulator have mandated a workplace exposure standard for diesel particulate, but that doesn't mean we don't have any guidance to work with. This project has adopted the recommended standard by the Australian Institute of Occupational Hygienists, which is 0.1 milligrams per cubic metre, as shown in the red line. All of our sample results are under that, and where you do see a few higher exposures creeping up, each one of those was followed up by additional management measures and additional controls so that follow-up samples were much, much lower. Our lessons learnt. We've got 4 key ones. Firstly, the strategy to control things such as diesel emissions really needs to be developed during the time of tender, as time of design, because that's where you get the most bang for your buck and you can really look at ways of eliminating the risks to start with and then mitigating the risks that you have by incorporating them into your procurement strategy. The extent of control that you will have over the control of diesel emissions will largely depend on your project contractual model and the amount of control you hold rather than subcontracting it out. Internal and external consultation is essential. I am but one of a very large team of people who have come together to work on this strategy. And with anything, monitoring and adaptation are key to ongoing continual improvement. So I know you've seen this photo before, but it is one of my favourite photos. It's the group of guys on day shift at one site, and there are 7, to give you a scale of it. And I think the key achievement to date is that concentrations of diesel particulate matter and associated diesel exhaust gases that workers have been exposed to on this particular contract are measured either below, but in most cases, well below industry standards. TGHD's strategy of designing out primary sources of diesel particulate matter and other diesel exhaust gases, procuring low emission equipment and implementing strategic management measures have helped achieve this positive result. The continued effectiveness of these control measures will be verified through ongoing monitoring over time, but outside of the data, the key or the best achievement to date for me has been the protection of what matters most, and that is these guys, the tunnellers that are actually delivering some of the major infrastructure projects in Sydney, in addition to the environment and the surrounding community. Thank you.